Hey guys, welcome back. So in the last video, we talked about why there are so many different types of linked list and which is the one we should be using in which kind of scenarios. Hope the idea was clear. Now in this video, let's talk about how is linked list stored in memory, that is RAM. So before understanding how is linked list stored in memory, let's recap how is array represented in memory. So let's say we have a 1D array whose size is 10 and the values that are stored in that array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's say this is our RAM. So as we can remember from our array videos, all the cells in a given array are always stored in contiguous memory location. That is, this array starts from this memory location. Let's say the address of this memory location is 001 and then it occupies the 9 consecutive cells out there. And this is the reason why in case of an array we can directly access any of the cells, because we know that, let's say if we want to access this cell, it will always be residing after 4 cells from the first cell. Similarly, if we want to access this cell over here, then we always know that this cell is at location from first cell plus 7 cells. But that is not the case with linked list, and that is why we can never access any of the node of a linked list directly. We always have to travel from the first node till we reach the desired node. Now let's see, if the same data needs to be stored using a linked list, how is it saved in memory? So here we have a linked list having 7 nodes in it. So the first node is 10, which is pointed by head. Then the next node is 20, which is pointed by 10, which is first node. The next node is 30, which is pointed by 20. Similarly 40, 50, 60 and 70. And 70, which is the last node, always gets pointed by tel. Now as you can see that there is a contrasting difference between how is array stored versus a linked list stored in memory. So here we see that we have 7 nodes and none of them are stored in contiguous memory locations. So one is stored at this location and the next location is blank. Then the next is stored at this location and you see the next cell is blank. Now this is the power of a linked list, that we can always create as many number of nodes as required at a runtime, because we need not specify how many contiguous memory locations should be allocated to this linked list. And this is the same very reason why we cannot access any of the nodes directly. Like let's say we are currently at the first node, and if we want to access the 4th node, we cannot do an address of this, that is 001 plus 4 and reach here, because we don't know where this node is stored in memory. It can be stored here, it can be stored here, or it can be stored here or anywhere else. But in case of an array, we always knew that the 4th cell will always be located over here. Hence, we can always do a 001, that is the address of the first cell, plus 3 and reach at the 4th cell. So I hope you would have understood how is linked list stored differently compared to an array. So I hope that by this time we have a solid understanding about the fundamentals of linked list. Now from the next video onwards, we'll talk about what are the operations that can be performed on these 4 different types of linked list. So that's all for this video. Thanks for your time. See you in the next video.